Okay, we're looking at rates of change. So how do they compare to slope of a line segment? Well, rate of change is really just the slope of a line segment, but it's sort of the real life example from an application question. So if we know some relationships between, typically rate of change is based on time. So how maybe the distance traveled relates to the time it takes to travel the distance, heights, costs per minute or hour, that kind of thing. So they are sort of applications of slope. So in the try these, all it's saying here is take 540 milliliters and divide by 3 seconds. So the units will be milliliters over seconds, right, per second. That's what it means. So we really, the rate of change is trying to find the value for 1 unit of time. So take 540 and divide by 3. If you're not sure what that is, you can use your calculator. It's 180. Part 2, 390 kilometers divided by 3.5 hours. So that's kind of like finding the speed that you've traveled. So 390 divided by 3.5 hours is 111.4 kilometers per hour. So it's highway driving. 13 divided by 3.2. We'll go to 1 decimal place, 4.1 meters per second, then liters per minute. So 450 divided by 9 is exactly 50. Didn't really need my calculator. Liters per minute. Okay, here's an application. Riley is a chef. He is comparing the rates of change in temperature of 2 ovens. These graphs represent oven temperature versus time. He wants to buy the oven that heats up faster. Which should Riley buy? So the graphs are there. They both start at time 0 at 50 degrees Fahrenheit when it's first tested. Same thing here. And then in oven 1, it's tested again after 6 minutes. The temperature is 425. In oven 2, after 5 minutes, the temperature is 375. So they're very close if you look at them in terms of their slope. You could actually like get a ruler out and just move it over, see which is steeper, because the scale is the same. They're both going up to, I guess, essentially 8 minutes, and temperature of, what's that, 550. And the scale is the same. If it wasn't the same, you couldn't compare it. But look here, so where this ends up at 8 minutes is lower than it is over here. So looking at this, after 8 minutes, this is going to be at a higher temperature. And it's a straight line. So I'm going to say it's oven 2, but we're actually going to do the calculations to check. So rate of change, as I said, is the change in one variable relative to the change in another. Typically, that's time. So what is the rate of change for each oven? So it's the change in temperature divided by the change in time. So for the oven 1, we take, this is our second point, and this is our first. So the Y2, 425 minus Y1 is 50, over X2, which is 6, minus 0. So that's going to be 375 over 6, which is 62.5 degrees Fahrenheit per minute. For oven 2, this will be our second point. This will be our first. So 375 minus 50 over 5 minutes minus 0. So that's going to be 325 over 5. And that's 65. So they're very close, but as I predicted, the second one is faster. The 65 degrees Fahrenheit per minute is greater than 62.5. So oven 2 heats up faster. So Riley should buy oven 2 because it heats up faster. Okay. Next page, example 1. Dylan was driving from Regina to Red Deer. After 4 hours, he had traveled 320 kilometers. After 6 hours, he had traveled 480. What was Dylan's average rate of change between those two time periods? So plot the points on the grid, join them with a line segment. So 4 hours, 320 kilometers. So 4 hours, 300. Okay, so 300 is here. Every grid is 50. So 320 would be about here. After 6 hours, 480. So it would be about there. Join them up. Of the line segment. So we need to go 480. So our second point. Oops, sorry. Let's get back in here. So this point is, oh, that's a line. This is 6, 480. This is 4, 320. So second point, 480 minus 320 over 6 minus 4. So that's 160 over 2, which is 80 kilometers per hour. So what does the slope mean? The slope is the rate of change of Dylan's distance against time. And so the rate of change is Dylan's speed. Anytime you're doing the rate of change of distance and time, really that's the speed that he's traveling. So average rate of change is his average speed of 80 kilometers per hour. Okay. Next one, Julia is a heating technician. She graphed the water temperature in a radiator system over a 24-hour period. What is the rate of change for each time interval? And then what happens in these intervals? Okay, so first between A and B. So you want to look here. So A is 0, halfway between 20 and 30 is 25. B looks to be, so this is going, each grid is 2. So this looks to be 7 hours and 45. C looks to be 12 and 40. And D looks to be 24:40. So the rate of change between A and B is 45. Oh, this says 24 here. So it looks, yeah, it's a little below 25. So this is telling us more exactly. So 24. And then 7 minus 0. So that's 21 over 7. Get your, and then that goes nicely. 7 goes into 21 3 times, so 3 degrees Celsius per hour. B and C. So our second point is 1240. So we'll go 40 minus 45 over 12 minus 7. So that's -5 over 5, which is -1 degree Celsius per hour. And then C and D, Y2 minus Y1 over x2 minus x1. So that's 0. 40 minus 40 is 0. And that makes sense because it's a horizontal line, which we talked about in a few sections ago. So the temperature increased. So if it's positive, it increased by 3 degrees Celsius per hour during the first 7 hours. Then because it's negative, it decreased by 1 degree Celsius per hour during the next, how many hours? The next 5 hours, that's denominator there. Then it stayed the same for the last, how many hours? 12 hours. 24 minus 12. So a negative means the temperature was decreasing. So we either use a negative or use the word decrease. Okay, so that's the end of this section. So do the practice and then on to 6.7.